Well, now we're going to do rational and irrational numbers. Exercise 1, question says, question A says, from the list of numbers, the list of these numbers, okay, write down the natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Now let's first start by defining what are those sets of numbers, okay? Here's a definition. The definition, natural numbers, for instance, are the numbers that we use when we are counting or ordering. You know, when we count or order, we don't count fractions or decimals. Okay, we don't start from 0 either. We just say 1, 2, 3, 4, etc. If we count an item, or when we're ordering things, we say this is row 1, row 2, row 3, etc. We don't say row 0 or a fraction, certain fraction for a row, nothing like that. Or another fraction for grades, or no, when we order or when we count, we use positive integers starting from 1. Now, in the list of my numbers here, let's see. Do I have positive integers more than 0? Let's see. We can say 2. We have 2. Yes, that's right. We have 2. We can write here 2. Okay. And now, what about square root of 9? Square root of 9 is also an integer because if you square root it, you get like, you can see here square root of 9 is equal to 3. So this will be equal to 3. So we say, I'll say, I know that square root of 9 is equal to 3. I can just write there. I'll say there and square root of 9. All these are natural numbers. Now, whole numbers then. Whole numbers says that the numbers that includes natural numbers and 0, not a fraction or decimal. So usually people say whole numbers are natural numbers with a whole, with the 0, the whole 0. Then if I need to write whole numbers in this list here, I prefer to do in ascending order. I'll go with 0, and then I'll take 2, and then I'll take also square root of 9. Okay, it's a whole number. What about square root of -4? Okay, if you check this in the calculator, this is not equal to negative. It's not equal to -2. If you try in the calculator, you will get an error. So it means it's not an natural numbers, neither a whole number. Now, integers then, it is said a counting number 0 or the negative of a counting number, no fraction, no decimal. So integers set encompasses all the positive and the related negative numbers. When I say related negative numbers are like, if I have 2, the related negative numbers of 2 is like -2, etc. Things like that. So all the negative, 0, and the positive integers. This is when we talk about integers. So now I'll look here. If I want to take it in ascending order, I'll start with -3 because it is an integer. Then I'll go like -3, and then 0, 2, and root 9. All these are integers. And then we're not talking about decimal number. We didn't ask us anything about decimal numbers here. And then the next question is rational numbers. What are rational numbers? Okay, here this says rational numbers can be expressed as a fraction, include integers and fractions or decimals. Yes. Okay. Rational numbers are anything of the form. It's basically anything of the form A over B. Anything that we can write in the form A over B, knowing that B cannot be 0, okay, is a rational number. Anything that can be written in that form. Now, can I ask, is -3 a rational number? Yes, it is, because it is of the form A over B, can be like over 1. Okay, so over here, I can take -3 over 1. Okay. I'll say here -3 because it can be written in the form A over B. Okay, it's like -3 over 1, and then I can take 3/4, and then I can take 0, and then 2, and then root 9. They're all rational numbers. Why did I place them? I was supposed to place them here. Okay. Let me just erase 3/4, 3/4, and then 0, and then 2, and then √9. Okay. Now, irrational numbers then. Irrational numbers are, as we can see, cannot be expressed as a fractions. So it's something that cannot be expressed as an example like pi or square root of 2. So we also have square root of 2 there. If you try in the calculator square root of 2, for instance, you try the square root of 2 and then hit equal. This is not converted into fraction. Even if you press S to D, it tells us like a long decimal number here. So because we cannot write square root of 2 in the form of a fraction, square root of 2 will be classified as a third. So here we have like square root of 2. And what about square root of -4, for instance? Okay, this cannot even be simplified. It's not, these are the type of numbers we called non-real numbers, because as we did prove it earlier, if I do like square root of -4, for instance, in the calculator, it's going to send the error message. It simply means this number is not a real number. Square root of -4 is not a real number. Okay, so and then they didn't ask us to complete non-real numbers here, so I leave it out. And the real numbers takes all the numbers, all the natural whole numbers, integer, rational numbers in integers. So the real numbers, I can write them here. Real numbers will be -3, 3/4, square root of 2, square root of 9, 0, 2, square root of -4. No, this is not a real number. This is a non-real number because in the calculator it sends an error message. Okay, thank you. Well, now question B says, state whether each of the following numbers are rational or irrational numbers. Now let's first define what are rational and irrational numbers. Here's the definition. Rational numbers can be expressed as fractions, include integers and fractions or decimals. So anything, basically it's anything that can be written in the form A over B, knowing that B cannot be 0, okay? Anything that can be expressed in this form is a rational number. And then something that we cannot write, okay? Something that we cannot write in the form A over B, okay, is a rational number. Now let's see. Cube root of 33. Usually sets are those square root that we cannot simplify, those square root that we cannot write in this form, okay? Usually square root or cube roots of prime numbers cannot be written in this form. So so this is an irrational number. You can check in the calculator. If you do like square root of this is cube root. To get cube roots, you press shift and then you press this square root symbol. Then they try to write 33 and then equal to, you see, the decimal parts is there is no part in the decimal parts. You know, it cannot be written as a fraction. So it is a third. It cannot be written as a fraction. So 33 is cube root of 33 is irrational. So I can just write next to it irrational. If I say I, understand I mean irrational. And then pi over 2, pi is also an irrational number. You can see that an example here. Pi cannot be written as a fraction. Even if you see the pi over 2, this is not This is not a rational number because pi itself cannot be written as a fraction, okay? So this is still an irrational number. So don't confuse here, don't say pi over 2 is a rational number. It's an irrational number because pi is irrational. Irrational divided by irrational is still irrational. And on this part, 4,01345. What's this? Okay. This is a rational number. Why? Because I can write this as a fraction. You know, if I use a calculator, for instance, I can prove it to you. If I write here 4,01345, and then I press S to D, or say just equal, and then press S to D, or maybe it doesn't show it like this in the calculator, but I can write it like 4,01345 over, okay, how much? 1, 2, 3, 4, 5 over 100,000. This is the form A over B I was talking about. Okay, numerator over denominator. So this is a rational. This is a rational number. I can just write R there next to it. Then, what about square root of 1 over 121? Now, if you rush to answer this question, you may say this is irrational. But now let's first see, can we simplify this? Yes, we can, because the law says, I'm right here, square root of 1 over 121. One of the law of exponent and radical goes together, says like if you have like square root of A over B, this is the same as square root of A over square root of B. Okay, so square root of 1 over 121, let me write the rule here. Okay, so this can be written as square root of 1 over square root of 121. Now square root of 1 is just 1, and then 120, square root of 121 is 11. So this is the form A over B, okay, A over B. So we can say that's a rational number. Now, square root of -2, this is, square root does not accept negative numbers. So this is neither, okay? It's not irrational, it's not irrational, it's neither. So this is neither, just say N for neither. Now, what about negative square root of 2? We need to be careful here. Here, the negative sign is outside the radical sign, okay? So this is an irrational number because square root of 2 cannot be written as a fraction, and there's a negative number out there. Now, someone may tell me like, okay, we can do the same thing here. If we do like square root of 2, for instance, you press SD, you say we can do the same thing as we did here, we can move. Now, it's not the case here. It's because my calculator screen is small, or your calculator screen can be smaller also. If you use a larger screen, you'll see that this decimal part will be continuing endlessly, okay? And then in the decimal part, there is no pattern. There's no pattern. There is no, numbers don't repeat, okay? Like here, for instance, it stops here, but for square root of 2, it's not that, it doesn't stop by 2. It's because my screen is small. It goes on indefinitely, and then the numbers don't have any pattern. So this will be classified as irrational number. So now, negative, and the negative sign is outside. It's still gonna be the negative sign is outside the radical sign. It's still gonna be an irrational number. So this is irrational number. I'll put I there. Now, square root of 2 over square root of 2. Okay, this can be simplified. You know that anything divided by itself, any number divided by itself is just equal 1. So this will be classified as a rational number because 1 is rational. 1 is in the form is of the form 1 A over B, because we can also say 1 is like 1 over 1. Okay, and then here we have like cube roots of 27 plus 1. Now, let me warn you, there's a common mistake students do. They will say, students usually may say, this is like a cube root of 27 plus cube root of 1, and then they say this is 3, and then that's 1, and then it's equal to 4. This is very wrong. We don't do that. Okay, we can't split the radical sign for a sum of radicands here. This is equal to the cube root of 28, and then cube root of 28 is third. Okay, is an irrational. Let's check it out. I'll press shift, and then I press the radical sign there, cube root of 28, and then when we hit equal, and then there is no part in this small part, so this is a an irrational number. Thank you. If you like the video, please remember to subscribe and like and share. Thank you. Well, over here, the question says that state why we may conclude that each number below is rational. Okay, the question says they are already rational, but we need to say why they are rational. Okay, remember what we were saying earlier, that rational numbers are any numbers that is of the form A over B. Note that B cannot be equal to 0. Otherwise, we're going to have division by 0, which is ruled out. Now, I'll say that for number 1, for instance, it is a rational number because we can write 1 3/4 in the form A over B. This is a mixed number. We can write it with as an improper fraction. So we do 1 3/4 is equal to we do, to write it as improper fraction, we do 4 times 1 plus 3 over 4. Okay, over 4, and then this is equal to 7 over 4, and then this is the form A over B. A over B. Now that was for question 1, and for question 2, same reason. Okay, we can do 8 times -3. Let me write -3 or -3 and 1 over 8. This is like -3 times 8 minus 1 over 8, and then this is equal to -25 over 8. You can check the calculator. If you do like -25 over 8, and then you hit equal, and then we press ST there, okay, which is basically -3 and 1 over 8. So this is also rational. And then for question question 3, 4 can be written as like 4 over 1. So this is the form A over B, same as -5 over 1. And then 0.52 can be written as 52 over 100. Okay, if we move the commas twice, we divide by 100. It can be simplified also, but I prefer, as long as it's the form A over B, is fine. Same also as here. This can be written as 1,212 over 1000. So this is the form A over B. Okay. Well, the question says that show that the following recurring decimals are rational. Okay, so now when we see numbers with the dots on top of it here, it means they are recurring numbers. So those are the numbers that repeat indefinitely after the comma. So and then to show that they are rational numbers, it simply means prove that the numbers can be written in the form A over B. Okay, as we said. We said that rational numbers are those of the form A over B, where B, the denominator, cannot be 0. Now let's start from example 1, which it's like 0,4 with dots there recurring. It simply means that this number 4 here will repeat itself over and over. So it means it is equal to 0,4, 4, dot, 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 4, 4, 4. The 4 will repeat indefinitely. Now, I prefer to say let x equal to 0,4, 4, 4, dot, 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 4, 4, 4. And I call this equation 1. Now, okay, because it's only one digit that repeats itself, okay, I will times this equation by a number with 1, 0. I prefer to choose to times the equation by 10, okay? So I times it by 10, it's gonna be like 10x. This will be like 10x will be, if I times the equation by 10, see what will happen. If I do like 0,44444, I times here by 10, and then this will be, I will have like 4 as an integer, and then 44444 with the decimal part. So this will be like 4,444 dot 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 444, and I call this equation 2. Now, what I will do is like I do equation 2 minus equation 1. So this will be like 10x equal to 0,444 dot 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 444, and then x will be equal to, oh no, that was 4. X will be equal to 0,444 dot 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 444. Okay, if I do, as I say, equation 2 minus equation 1, 10x minus x, this is equal to 9x. Okay, and then 4 minus 0 is just 4, comma, and then 4 minus 4 is going to be 0, 4 minus 4, 0. So this will be simplified, okay? And then it's going to be like 0, 0, 0 there. And you know, once it's zeros after the comma, we don't really need to write it. So now, so basically this is just 9x is equal to 4. Now to get the value of x, okay? X, remember that x was the recurring value. So I will divide both sides by 9. I divide here by 9. I divide it also by 9. Now this means x is equal to 4 over 9. So this tells me that this recurring decimal can be written as 4 over 9. Now, if you're unsure, you can use a calculator and see. If I do like 4 over 9, and then I press equal, you see, I press SD, it says like 0. In the bracket 4 there simply means the decimal 4 occurs, it's going to be 44444, like as we see here. Okay. Let's see question 2. Question 2 is 0,21 dot dot. Okay, now the fact that you see a dot on the 2 and on the 1, it means these two numbers here, these two digits here repeat. Okay, so it's gonna be like 0,21 21 dot 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 21. So that 21 21 21 21, you repeat in that order, 21 21 21 21 21, etc. Now I'm gonna do a similar process like before. I'll say let's x equal to 0,2121, this number, okay, 21. I call this number equal, I call this number x. So I'm trying to prove that it is in the form A over B as there. Now, because there are two digits that's recurring, I'll times here by 100, not by 10, but by 100, because there are two digits that repeat. So I'll say, if I times, I call this one equation 1, okay? And then equation 2 will be like, I times here by 100x, and then this will be what? 21, comma, and then it's going to be 21, 21, dot, 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 21. If you're unsure, check in the calculator. If you have like 0,21, 21, 21, 21, 21, 21, you times that by 100, you see, you first have 21 as integers, and 21, 21, 21 will repeat indefinitely, okay? So we call this equation 2. Now, let's do equation 2 minus equation 1, okay? So this will be then 100x, okay, equal to 21, 21, 21, 21, etc. 1. Now, and then x equal to 0, 2, 1, 2, 1, 2, 1, dot, 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 2, 1. Now, if we do, we simplify 100x minus x is just 99x. And then 21 minus 0 is 21. And then you notice that these decimal parts here will cancel. Okay. So if I need to guess the value of x, I'll divide here by 99. I divide it also by 99. And then I have x is equal to 21 over 99. So this is proven because this is the form A over B of this recurring decimal. You can check the calculator. If I do, for instance, 21 here, 21 over 99, it's equal, and then we press ST there, you see, we have like 21 in the bracket in decimal part, simply means the 21 repeats indefinitely. Okay. Over here, now let's see question 3, for instance. Question 3, that says 0, 1 and then 4 dots. So let me write it here, question 3. We have like 0, 1 and 4. This simply means it's the 4 that repeats, not the 1. So this is like 0, 1 and then 4, 4, 4 dot dot dots 4. So this is the only digit that repeats. Okay. Then in this case, as I was saying, only the 4, 1 and 4 are 1 and the 4 recurring are both on are both decimals parts, okay, and then but only four repeats. Okay? So in this case, I will first say let x equal to 0, 1, 4, 4, 4 dot 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 4, 4, 4. Okay. We will multiply here by 10 first, and then see if I multiply by 10, because I want to get rid of this one here. Okay, this will be like 10x will be equal to 1, 4, 4, 4 dot 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 4, 4, 4. Okay, now if I do equation, this is like equation 1, and that's equation 2. If I do equation 2 minus equation 1, I will stack here because I cannot do 4. If I do 4, or maybe we may not stack like that, but what we can do, okay, let's just do this way. We have like, if I do equation 2 minus equation 1, equation 2 minus equation 1, this will be 10x equal to 1, 4, 4, 4, 4 dot 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 4, 4, 4, and then they have x equal to 0, 1, 4, 4, 4 dot 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 4, 4, 4, and then if you do 10x minus x, this is 9x, and then 1 minus 0 is just 1, and then 4 minus 1 is 3, and then the rest will be simplified. Okay, this will be simplified, that will be simplified there, and then this makes 9x is equal to 1.3, and then this will make that x is equal to what? I will divide here by 9. I divided by 9 in order to have x, and that makes like 1.3 over 9. Now let's use a calculator. If I do like 1.3 over 9, and then this is equal to 13 over 90. If I press ST there, it's 0, 1 and then 4 recurring. So this is x equal to 0, 1 and then 4. 4 recurring. So, and then this can be written as 13 over 90. Okay, it's the same thing. So the fraction is like 13 over 90. We times by 10, we times by 10 the denominator to get an integer there. Okay, let's move. Question. Same way we did question 3, we can also do question 4. Okay, we can also do question 5. Remember here we have like 3 digits and then one recurring. I have to skip this one, and then I can do question 6 because the 2 in between 2 recurring numbers means all these digits. I'll say the digits between 2 recurring digits means they also repeat. So let's do question 6 here. Question 6. When we have like 1 dot, no, it's 0,1 dot, 2, 4 dots, it simply means this is 0,124, 124, 124, etc., etc., 124. That's what it means. Now, I'll say x, let x is equal to 0,124, 124, dot, 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 124. 124, we can just write as many 124 we want. Now, to simplify this, I will times here, because there are 3 digits, I want times by 10, not by 100, but by 1000. I'll say, I'll times here by 1000, so it'll be like 1000. X will be equal to like 124, 124, 124, dot, 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 124, 124. Now this is like equation 1 and that's equation 2. Then if I do equation 2 minus equation 1, okay, so this will be like I'll say here 1000. Let's say 1000x equal to 124, 124, 124, dot, dot, dots, 124, and then x would be like 0, 124, 124, dot, dot, dots, 124. Now, because we're doing equation 1 minus equation 2, this will be like 1000 minus x is 999x equal to 124. And then all these decimal parts will be simplified, okay? They will be simplified, and then if I need to get the value of x, I just want to say x will be, I divide here by 999, divided by 999, and then this will be 124 over 999. So this is the decimal part. So the same thing will be applied with okay, that's for the last case. So the rest of the questions can be done in the same way. Don't worry about the negative numbers, just the same process. Okay, thank you. So if you like it, please remember to like, share and subscribe. Thank you.